Hi there, my name is Thomas from RobPathRec. I will guide you and show you today how easy and fast you can set up our tool, the RobPathRec Easy Robot Programming Tool, with RoboDK with any kind of robot or cobot. Yes, you heard it right. So we support almost all of industry robots and almost all of the cobots on the market, which are supported by RoboDK. For the demonstration by today, I will use an Allied Robots CS63. This is the smallest cobot in their series, but this is excellent for the demonstration, on which I will show you a couple of stuff on the hardware as on the software. So stay tuned. Okay guys, so at the very first I would like to show you where you can reach all of the necessary software and the hardware what you need for this very easy robot programming. So first please go to RobPathRec.com. Here you can find something about us. You can find always free of charge resources about our solutions. How you can set up, so all of the installation guides, the new features, we will keep it up to date so you can reach here always all of the necessary information for completely free. So if you need our software and RoboDK and our hardware for your start or for later, then please visit our shop. You can find it in the menu, and basically you need to use our solution. Besides our RobPathRec app, you need the RoboDK software. All the licenses you can buy in our online shop, and for sure you can get our hardware kit as well, which is necessary to be able to use this solution. About the licensing and the fees, I will tell you later on. First, I would like to show you what happens if you go through as in a normal online shop and you just complete your checkout. So to be able to buy anything, for sure, first you have to register. Okay guys, so after login, you are just coming to your personal dashboard, and from your dashboard you can manage your orders, your license keys, your application and your downloads. So in the download sections you will find everything what you need. Here you will find, for example, install the RobPathRec 1.13.zip. If you hit this button, it will be directed to you to our drive, so please just ignore this message and go to download anyway. You can download this package. This is a zip file. Then you have to unzip it, and once you do this, I'll just go to the downloads. Once you do this, you will get a RobPathRec installation file. This file is approximately 2 gigabytes because of the integrated components which we need for our functions. And for each update, this is the same procedure. So if you will be notified in the future that there is an update available, then you can go always to your dashboard. So you please go to the shop. Here you can add the new app to your cart. It's free of charge. And if you go to your dashboard, then you will find the latest downloads here, and you can download it, unzip and install. Okay, I will skip it for now as we already installed everything, and I start immediately with RoboDK. RoboDK is the same. You will get a link where you can download RoboDK once you purchase the license. So after the installation, you can just simply start RoboDK. I have it in my shortcuts, so I just start a completely new and fresh station. I just start with the saving. RobPathRec Setup. demonstration. And then you can see that this station file gets automatically this name, and as I saved it to my desktop, this appears on my desktop as well. As the next step, you have to download your robot. Some of the robots are already in the library. Anyhow, RoboDK and RobPathRec is installed on the C drive, RoboDK, and here you can find all of the RoboDK files, and here you can find the RobPathRec files below. Right now we don't use it because I recommend you always to have the latest RoboDK, so opt in for a maintenance as well. After the first year you have to opt in for a maintenance package, and then you can always get the latest features coming with RoboDK. If you hit this button, then you will be redirected to the RoboDK library, which can be reached by the website as well, and this is free. And right now I'm just typing in Allied Robots, and you can see here a couple of them which are already included in RoboDK. I have the CS63, so the smallest one, and I just hit open. Once I do this, you will see that this will be automatically imported in a correct way into RoboDK. It's so easy. Anyhow, just for your information, you can see that here are a lot of other brands. You can see as well how many devices are supported from each brand. Sorry. So this is really a huge library. Will be improved and completed further on. So I can recommend you that if you are not sure if your robot is supported, just come to RoboDK, come to the resources library, and here you can see if your robot is already included. But you have a lot of other stuff. You have stations, ready to use stations in RoboDK. For sure you have add-ins where you can find from RobPathRec as well a tool. Okay, as next we will connect the robot with our PC. For this we will use the integrated driver within RoboDK. So first you just please check out if you right click on the robot. Sorry, you can go to connect to robot. Anyhow, you can use this function under the connect menu as well. Once you have it, you will see that here we have to define the IP address, the robot port. In this case, I just check out if the driver is the correct one. I just check this and I see, okay, this is really the driver what we need. Okay, how can I figure out the IP address of the robot? So therefore I switch to the teach panel. In my case, I have to come to the settings, and under the settings I find the section network. Here please take care about that you are not using a DHCP, but you are using a static address. In my particular case, this is 192.168.0.5. Within this subnet mask, and my default gateway is 192.168.0.1. So I will go and I will adjust the same settings. So I'm just coming to the settings and my Windows, and I come to network and Ethernet, and here this is already predefined, but if it's on automatic, please choose manual. Then on the IPv4 for this particular PC, I give right now the 192.168.0.100. So the robot had 105. I think. No, this is the robot had only 5. So the last 3 digits of my IP address is 100. the gateway must be the same, so they are in the same network. We do not need the IPv6. Just hit save. An additional stuff is the firewall, which should be turned off completely to be able to use the connection. So my public firewall network is active, but the private network and the domain network, they are off in this particular case. So once we have it, I just have to type in the IP address of the robot. And the robot port in my particular case is really 3 times the 0 and 1 times 1. Which kind of port and which kind of IP address, this is always depending on the manufacturer. In my special case with Allied Robots, with this particular model, this is the right setting. And for sure, I already connected my controller and my PC with a TCP/IP cable. So please do not use USB or any other stuff. Use the old LAN cable. So if I hit connect, then you will see that the robot is already connected. And if I hit get position, then nothing happens. Why not? Right now, at this particular model, I am still in the local mode, so I just have to switch to the remote mode. I will build up the connection again. And if I hit get position, then you will see that this is exactly the same position what you can find in on the real robot at the moment. So as a next step, we will define and add a tool TCP, which is in my case this tool. For this, please let me change here the setup. We just choose the right robot. This is the only one in the station at the moment. I right click the robot in the tree, and you have different kind of possibilities to add a tool. You can add the tool TCP from a file, you can attach a tool directly which is already loaded, or you can just simply add a tool TCP, that means tool center point coordinate system. If you gonna add it from a file, then you should navigate it to RoboDK, and you can, I think, use the library. And here you can see that there are Weltgun and other tools which are predefined. For sure, you can import your own tools as well, and you can use them. But for our system, this is not necessary to have a CAD model of a tool. You can just simply add a tool TCP, so a tool center point. You will see that this is at the moment added here. If I show head, so this is the tool one, this is the tool one. I will just rename it, hitting F2, and I rename it to pen. Okay, so you can see this is very important, that the coordinate system of the tool at the moment is absolutely identical with the coordinate system on the flange. Yeah, so the Z is showing down, X and Y are showing exactly in the same direction. So right now what we will do is a very simple task. I will move the robot to this position first with the free ride mode. Wait a second. So we just switch it on here. And with the free ride mode, I'm just coming approximately to this point, and I will use the jog to come exactly to this point. I recommend you to lower the speed so you can adjust it more precise. This is a very crucial step to complete, because this will define where is the pen, the tip of our pen, or your tool, your weld gun, or your spray gun, whatever. So the more accurate you do this, the better results you will get later on. Right now you would have different kind of options. We have to define this TCP, this tool TCP to our system. So you can right click on the tool and you can hit define TCP, or you can come to the utilities and you can choose define tool, tool frame TCP. I will just use it from here, so define TCP for this tool. You can see that we have a very similar setup. So I have a spike here, and I have to move the tip of my particular tool to the tip of this calibration tool. Please always check out that you are calibrating the right tool, you are calibrating the right method. So with points, you are using joints, very important that you are not using poses, but you are using joints. And please take care that you are using it for the right robot. Okay. If you want to higher the accuracy, you can type in more positions. I will stick to the minimum of 4, which is recommended. And you have two possibilities. So these are the joint coordinates, the fixed coordinates, which we should type in, and these are the coordinates here on the screen on the teach pendant. So either you can choose it, really type in manually. In this particular case, this will minus 16, no, 16, 70, 70, 16, 77, and so on and so forth. But as we connected our PC with the robot, we can use the get position function once we switch back to the remote mode. So once again, let's connect, get position. So, and right now you can see that the robot on the screen exactly has the same position, and now I has nothing other stuff to do, just like hit the get P1, and all of the points from the teach pendant will be copied automatically to RoboDK. And we will do this the same manner right now for the other 3 points. So I just make the rough alignment by my hand, and then I come back to local, to the jog. I really recommend you to take enough time for this section, because this is one of the most crucial. If it's not precise enough, then all of the other stuff, what you will do later on, will be unprecise as well. So I'm switching back to the remote mode, and I'm hitting get position. This is the new one. I copy the coordinates, come back to the local mode, free ride, joke. Back. This is always depending on the actual robotic system, how you can move it. If you have steps in millimeters, or you can really just fine tune it with the speed. In this particular case, we have to do this with the speed. So I'm just switching back to the remote mode, connect, get position. Okay, get position 0.3. You can always double check if it's really the same values. So these are the same values, it's rounded, but this is the same value. And let's choose the last one. Basically the more it differs, the better will be the result. So avoid choosing very similar positions. Okay, this is a little bit tricky for me with the many cameras on the desk, but I think I am on a quite good way. Okay, let's take it this way, remote. I just connect. Hit the get position always. It changed already the position, but hit the get position please, to make sure that this is really the same position what you can see in the reality, and then get P4. So here you can see this is the TCP arrow, so this will be updated if I hit the update button, which I do now. You have to confirm again. And now you can see that this is the new actual TCP what we have, and I would say this looks pretty well. So this was only in the Z direction for sure. This is a concentrical tool. This is clear. Right now I'm just coming back into free ride mode. Okay. So we can update the last time the position on the screen. Just connect. So, and you can see that on my screen the robot stays exactly the same way as it stays in the reality. Okay, let's move to the next section. We will define the so-called user frame. This is the area where we will work later on. By the way, it's quite important. You can place this calibration tool anywhere where you can reach it with a physical robot. So there's no particular or dedicated place for this. You can place it anywhere. It's just crucial that during the calibration, you are not allowed to move this part. If it moved, then you have to start from the very beginning. Okay? Okay, as next, we have to define a user frame. The user frame is the working area where we will use further on. I will show you with this example that we are using a similar coordinate system like this origin X and Y, which I have it on this clipboard. This is the origin. There is my X and there is my Y point. Why it is important? Because we will use the same clipboard later on a remote place, on a different place, to make the recording, and we will still use this robot space to completely copy our movements. So what we have to do, we have to copy this clipboard area, so the 3 coordinates, this layer, exactly this layer with these points, we have to copy into our RoboDK station file. How we do this? So I just come to the world coordinate system of the robot, and I'm just adding a new reference frame. Here we go. I just rename it. My user workspace, or my workspace. So this is the so-called reference frame. We have to define the reference frame, what we can do on a way that we can hit with the right click the reference frame in the tree, and we define the reference frame. Or you can navigate always from the utilities, define reference frame or user frame to the same position. So here I define reference frame. Here you have different kind of options. First, please always check out that this is that you will work on the right selected reference space. So this is my workspace, this is okay. Secondary, please always check out if the tool for which you are using your TCP is the right one. In my case, this is the pen, so this is the correct one. You can see that there are different kind of versions of the calibration. So here on the camera image, you can see that here we do not have any X corner. So if we would like to use the outline of this clipboard, we could use this version as we have a rounded corner here. But in my particular case, I have the origin, the X and the Y, therefore I'm using the second one. Very important that we have to choose the right robot, and we are still working with joints, okay? So no points, no poses, we are working with joints. Okay, the procedure will be exactly the same like before. So we will move with the tool to these particular points, and we will copy via the driver, via the connection between the controller and the PC, the positions. So let's start. I'm just coming back to the local mode and activate the free ride, and as first I am coming to the 0 point. This is important again, that you should point it as precise as possible. So okay, I hope here you can see as well, yeah, it hits quite good the 0 point. So I will switch back to the remote mode. Connect, you can see that the robot position on the screen is already adjusted, but for safety, I just hit once again the get position and get B1. You can see that on the jog, the coordinates of the joints are the same rounded values what we can see on the screen. So the next one is based on the calibration, is on the x-axis. So I'm just coming to the freeride mode, and we just try to get it as exact as possible. Okay. Please keep in mind that for the jog, the X and the Y coordinates on the jog control might be different than on the coordinate system what we have, so you have to try around a little bit. In my case, this is a little bit different as well. Okay, I say that this is good enough for this demonstration, so I'm just connect again, get position, get B2, check it again on the jog, and it is the same, so we can move on to the last point, which should be somewhere in on the surface, somewhere on this layer. I will still come, oopsie, I was a little bit too fast with, so I will hit the Y point, at least I try it. So this is good enough for our demonstration. Just check out the values, and just import the values into the calibration screen. Bam, so we are done. And once I hit OK, you see that my workspace was moved exactly to the place where we need to have it. So we are almost complete. Okay guys, so before we move to the next step, we have to check out if the tool TCP and the user frame is really defined correctly. To do so, we will move the robot to the 0, the X and the Y position, and we will check out if the coordinates what we can find for the tool TCP are approximately correct. This is a little bit complicated to do this completely alone, but never mind. Okay, so I'm not taking care about to hit exactly the points. I would just like to see approximately 0, 0, 0 for X, origin XZ, and for this origin point for the X, Y, and the Z coordinates. So to do so, we switch back to the remote mode, and we just connect again the robot. So here normally you should go with a right click to the options, or you can hit F3 and then you will land in the robot jog mode. Very important, as per default you will see that he is referencing to the word coordinate system of the robot. you have to change to your reference frame, to the actual reference frame what we are using, and this is the My Workspace. So, and here you can see that we are approximately on the 0 position for each 3 coordinates with the tool. Now I just change to the X point. I'm just coming in the freeride mode to this X coordinate. I'm just hitting a little bit deeper with this with the tool, so the Z will be in a plus, and that means this is 297 on the X. The Y coordinate is approximately 0, and as mentioned, I just put a little bit down, so this is 1.2, seems to be fine. So I'm just check out the last point. Oops, I was too fast. Okay, and just make the last movements with the jog. Once again, I don't want to hit it exactly. It is just to see if the values are approximately in the correct range. Disconnect and connect again, get position, and you can see X is about 209.5 and -4. So this seems to be good enough. That means we can really switch to the next step. Okay, as a last one, before we can start with the first recording, we should define a home position. The home position is necessary because for many cobots, the configuration might be a little bit strange of the robot with regarding the home position, and we want to make it sure that the very first position what you are going to is always a predefined position, so you can reach all other steps later on a correct way. To do so, I will switch on the the freeride mode, and I just try to find a position with the robot which is on each axis a kind of position where we do not have any perpendicular positions to the axis to the robot, so we can avoid any kind of singularities. If you would have this kind of position, which is a very regular one, then it might happen that some robots will come into a singularity. So we recommend to come into a position, as you can see on the screen as well, which is not 90 or 0, so these are all of them are not straight numbers. Okay, so what's the next on the screen? We have to add this position as a home position. So we choose the word coordinate system and we add a new target. This new target should be renamed with F2, and this is important at this version, that you should call this J home. J is small, H is capital, and the rest is small as well. Okay, so J home, this must be called. So we will work on 2 changes in the future. Important again, you should choose joint target. This must be a joint target. So we will define the angles in each axis for each joint, but we are not only defining this position. So this will always exactly this axis configuration what we will reference as a home. So right now we just check out. that we switch back to the remote mode. We connect the robot again, get position, and very important, just right click this new created J-home, right click, and then teach current position. Okay, so right now we have everything what we need for our recording. We have a valid robot, we have a tool, we have a workspace. Both the tool and the workspace are the active one. And we have a J-home home position, which is most probably help us to avoid any kind of irregular movements of the robots later on. So right now we can go over and we can do our first recording with the RobPathRec tool. Okay guys, so we defined everything on the screen and with our real robot. So I propose that we move into the next room where I prepared a recording room for us. For this purpose, you can see here that on two tripods we have our laser boxes. There is the other one. Here's the other laser box. So you can see there that for this workspace, I just applied a setup where both of the laser boxes can clearly see onto this area where we will do the recording. So for this, on this clipboard, you can see that we have exactly the 0, the X and the Y point on the clipboard. Okay? Here you can see our device on the desk. I would like to explain you some stuff for this device. So the small openings on the device, they are photodiodes, and we must hit with at least 2 laser beams at least 3 photodiodes that we can figure out what is the correct position and orientation of the tool. In each of the laser boxes we have 2 lasers. One is scanning horizontally, the other one is vertical. So as we have 2 laser boxes in this room at the moment, we have in total 4 laser beams. So we have a very high probability that we can always hit at least 1 diode on this tool. You can see additionally that the tool is a symmetrical one, so it is available for right-handed and for a left-handed operation. You can see that we have 4 hardware buttons on. With the hardware buttons, I will show you later on, you can choose which kind of function do you want to use. So you can choose it free, this is your own decision. And you see some strange openings on this tool. With these openings, I will show you later, you can apply adapters to this tool, and with the adapters you can fix it on any other manual tool or on any other, you can attach any other adapter which might enhance the usage of this tool. So let me just complete the setup here for this room, and then I will show you how to do the first recording. Okay, so we have our predefined RoboDK station file here, and we have the RobPathRec teach pen. Very important, for each RobPathRec kit you get an USB adapter what you have to attach to your PC. The USB adapter can be driven only if you have a PC with a dedicated graphic card. Okay, so the integrated graphic cards will not work. This is because of the Steam VR software what we are using. This is the requirement of Steam. So you can check on our webpage or at Steam what are the minimum requirements regarding the graphic card. We can give you hints as well which kind of pieces can be used if you want. So I just switch on the tracker, and you can see that this is everything in a search mode. So I'm just started the Steam VR software, and as you can see, we have the two laser boxes and we have the tracker. This room calibration setup sometimes popping up. We do not need this. You can click it through that you won't be reminded again, because if it's just only closed, then next time this will open up again. You don't have to type in any kind of values for it. Just click it through, setup complete, and forget it. So dismiss. So once again, here we have the base stations, the both so-called base stations, and we have the tracker. Okay, so the Steam VR software must run, and the tracker must have an active connection to your PC, and the RoboDK station file must be opened with the minimum configuration: one valid robot, one valid calibrated tool, one valid calibrated frame, and one J-home. If you have all of this, then you can fire the RobPathRec app, which I just have done right now. It takes a little bit. Okay, now I just started, sorry. So it takes a little bit that we check all the configuration, we check the license, we check everything in the background for you. And if everything is right, then soon the RobPathRec window opens up. Which kind of functions and what you can find here? Just a very short one. We will you can find it on our website, all the functions, and I will give you later on with videos for each function a demonstration. So basically you have to make it sure that the robot, the tool, and the frame is the correct one is selected. Right now we have from each component only one, so you can't choose anything. If you would have several tools or several frames, then you would be able to select it from the drop-down menu. The offset to the frame is actually -2 millimeter in my particular case, because this is a safety offset that I want to move above the frame, but for this demonstration I just set it to 0, just like the offset to the tool. So these values are given, so if you hover with the mouse, then I think yeah, there's the help. So you can see the coordinates, the X, Y, Z, and the rotation RX, RY, RZ. So these are the coordinates what you can manipulate. You can, and you should give a program name. You can decide if you want to record the orientation or if you want to record it with one orientation and just the coordinates. And there are some additional advanced features as well. So for now, I will just hit the start recording button, that you can see what happens. So at the start recording button, we have to calibrate our workspace, and with this calibration we will check the accuracy as well. We could use for sure always as a workspace definition this sheet as well, but basically you just have to go to the predefined 0, to the predefined X, and to the predefined Y points. For sure, if I would have used at the very beginning at the setup this piece of paper as the user frame, then I should use these values, okay? But right now I'm sticking to this one because this is my user frame, what we defined earlier. So I just hit one button. Then I go to X, I hit one button. I go to Y, I hit one button. And right now you can see on my screen that the robot is already moving and following the movements of my hand, okay? And now I'm just coming back to the 0 point to check the accuracy, which is, at this particular case, is 0.85 millimeters. This is the accuracy what I could reach with my optical system right now, okay? If you have an inaccuracy with your frame calibration on the robot or with your tool calibration on the robot, this accuracy is on top, so then this would be added. So if I would have 1 millimeter inaccuracy on the tool TCP, then in total I would have right now 1.85 millimeters. Okay, what I will do right now, I come here as a start point, so I hit one button. I will define this coordinate system. So here I come to the 0 point, one button. I come to the X, one button, an intermediate point. I come back to the 0, one button. I come to the Y, press one button. So what we will do now, from this point, I will come to here, move linear to the Y, come back to here, move linear to the X, and right now to the Y, okay? So we will create the coordinate system. Next step, I come back again here, somehow to this point, and I will hit another button which will trigger a continuous recording. And you know what? I will copy the 3 letters, okay? The sound, what you can hear, this is an acoustic feedback, so I don't have to see on the screen or watch the screen to see if it works or not, because I can hear. Okay, and additionally, I would like to copy this one. Okay, so that's all. If you want, you can visualize the pan on the screen. So you can see where is the pan with which orientation, yeah. So I think this is a useful tool. If the orientation would be not the right one with the pan and on the robot, then you can just simply rotate the tool TCP to get the correct orientation for this. Then with the plus minus buttons, you should be able to adjust the size of the coordinate systems, and you can see what we already recorded, okay? So if you think we are ready, then you just simply hit finish recording. You can say you can see we saved 300 points within such a short time. So I just finished recording. And right now we are ready with the tool. You can switch it off if you want. I just let it on. I do not really care about. So, and here's the program what we created, okay? And here you can see if the robot can go through. So you can simulate on the screen at the very first time if you can come through at each point, if you can reach it. Here this is a little bit advanced view, if you can reach all the positions with your robot. Seems to be the case. So I think this is right now fair enough. And what we will do, I will move back to the robot. I will connect the PC with the robot, and we will test on some particular points if we should align any kind of offset. I'm talking about right now, especially about the Z. We can fine tune it in front of the robot, and if we think we are ready to go, then we can, with some mouse clicks, export and transfer the program to the robot, and we can start it from the treatment then. So please follow me and let's do the last steps. Okay, so guys, it seems to be ready. What we will do right now, I just turn this piece of paper and I just place it somehow that it should fit our needs. Okay. So what we do on the screen, we will go to some particular points which might be on the paper, and we just build up the connection with the robot. And we just say move joints. So once again, what I would like to, with a low speed, so this is important right now, we are on a quite low speed with the robot. I would just like to see if especially if the Z coordinate is a correct one. So you can see here we are slightly above the paper. So in this case I would really come to the local mode with jog, and here please take care about the pay attention about the Z coordinate. So this is 84.66, and with low speed we just hit the paper on a manner that we can make it sure that with our pen we can write. So this would be for me approximately 3 mm offset. Okay. So what I will do, I will select all the points which we recorded, and I will apply a relative tool shift in the Z direction 3 mm. So the Z is showing, the Z positive is showing to the bottom side, so out of the pen this is the Z positive, so I'm just going 3 mm plus . So just stop it. Okay, so once again I just connect. Okay. Obviously I messed up a little bit. Never mind. So once again, move joints. Come on, just do this. Oh man, I just forgot to switch back to the remote mode. So, okay, once again, connect. I come to this particular position because I know that this is on a higher level, so I stop it. I don't want to go really there. So, and I come back to the point 3 just to see if we hit the paper with the tip of the pen. Okay guys, this seems to be good. That means I will raise the speed and I will send him to the home position. Okay, so we can export this. I just rename it. And I just generate the robot program. For this, I forgot to show you something before we generate the robot program. It's always good to see if the right post processor is selected. So here's a generic post processor selected. So this is not really good for us because this will only create a step file. So we choose as a post processor this Allied Robots CS task. And generate robot program. So what we are doing right now, this looks better. What we are doing right now, this creates a task file, and if we hit this explore button, then a FileZilla will be opened up, and this will connect or try to connect automatically to our robot. Which are already predefined, the values for this. And you can see that this is the task file. So we do not need the text document, but we need the task file. I'll double click it. The transfer was finished. So here's the task file. So, and now I can switch to local mode. I can hit open task, and here's the program which we created. I just open it up. And each point which we created will be read in. So there is a transition radius which is this smooth value, so you can make a smoothness on our file. With the smooth value 3, maybe we will have to adjust it. I just try to start it. So this is the first point which we recorded. What the heck? Okay, what happens? Okay, my robot got a little bit unresponsive. Okay, we just seen that on the letters I need some offset. I just close the Steam VR because we don't need it. Make it full screen. So how we do this? Okay, so it starts here. At 0.8. Okay, so here we are. I'm just looking for the last point at the letters. Okay, at the B. So it goes okay, never mind, this was not what I wanted to do. Okay, so this was the point, and we want to apply a tool shift 2 millimeters. Okay, and we want to apply to the rest 1 millimeter. Okay, and just rename it Setup 2. Come to FileZilla, refresh. Oh, for sure I have to create the program. Generate the program. Okay, it's complete. This is the previous one. So right now I can refresh and upload. Okay, now we just choose the new one. And start again. Okay, so the coordinate system again. At this point, I would like to point out some features. So keep in mind, we programmed the robot completely offline. We just need a couple of minutes for the fine-tuning regarding the offsets. First one. Second one, this is a freehand operation, so therefore please be aware that you can see the inaccuracy. This is because right now I was writing everything freehand. For sure, if you are using kind of template, physical template out of paper or something which guides your hand, then the recorded lines will be far more accurate. However, I think it looks pretty good. So I want to show you how it looks like. I think the result is fine enough after the teaching only a few minutes. So if you have any questions, do not hesitate to reach out to us. And as mentioned, we will upload continuously videos with the functions, how to set up and how to use the program. Good luck for your recordings. Bye-bye.